At the top of the screen, I've given you a couple examples of inverse functions because I want you to notice, hopefully, a very simple pattern. I've given you an exponential function, something we've graphed before. F of x equals 8 to the x power. Notice the inverse of something exponential has a logarithm in it. Specifically, log base 8 of x would be the inverse of 8 to the x power. Over here, I've given you 2 to the x power, something exponential. Notice its inverse is something logarithmic, and specifically it's log base 2 of x. So an exponential function, its inverse is something that has a logarithm in it, and vice versa. And hopefully you're seeing a very simple pattern with our bases. So let's go ahead and try to use that pattern to find an inverse function. Now you may recall from our previous unit, we found inverse functions in the past by switching x and y, and then solving for y. And while we can still do that, I think these top 4 down here can be done much easier just by following a simple pattern. So I've got something exponential, y equals 6 to the x power. To find the inverse of something exponential, I know it's going to involve a logarithm. So my inverse function of 6 to the x is going to be log base 6 of x. And notice log, y, and x, they're all kind of on the same level if I'm writing that on the line of my paper. There's no exponents in there. That 6 is just dropped a little bit lower as a subscript, okay? That's my inverse function. It's as easy as recognizing that pattern. Y equals 10 to the x if we go right below that. It's exponential, so my inverse is going to be something logarithmic. I'm going to write that since my base is 10. My inverse is going to be log base 10 of x. Hopefully you're seeing the pattern, and this is coming really simple, because that's as easy as it can be. Now remember, we could also just drop off that 10, since we have the common log right there. I could just say y equals log of x, would work as well. Okay? Let's try the reverse of that, so let's move over to the right. I've got 2 things that are logarithmic. Well, the inverse of something that's a logarithm should be something that's exponential. So log base 12 of x, the inverse of that is just going to be 12 to the x power, just based on some patterns that we're noticing. Be careful, sometimes people will tell me the inverse is 12 times x. Be careful that the inverse of 12 times x is 12 divided by x, so watch out for something like that. For the natural log of x, remember what base we have when we're dealing with a natural log is a base of e. In fact, I can rewrite this same problem as log base e of x. The inverse of something that's a logarithm will be something exponential, so y equals e to the x is going to be my inverse function. Okay? So there's a few easy examples. Let's go ahead and really challenge ourselves though, and let's try a couple more where it's not as easy as just following a pattern. To do these, I'm going to go back to what I had mentioned at the beginning with the old way that we found inverses by beginning by switching x and y. So let me rewrite this problem as x equals e raised to the y minus 5. And now what I want to do is get y by itself. Not surprisingly, since this is exponential, we're going to end up with something that's a logarithm, and hopefully, as some of you are thinking, since this has an e in it, I'm probably going to have natural log. If you're thinking that, you're right. So here's what I'm going to do, and this will become much easier in future lessons after we do some solving. So if this is really, really challenging to you right now, don't worry, trust me, it's going to become much easier in the future. If I want to get rid of a base of e, or any base, I'm going to do a logarithm, and specifically to get rid of a base of e, I'm going to do the natural log to both sides of this problem. So I'm going to end up with the natural log of x. When I do the natural log of e, those are inverse operations. If you watched our previous video, we talked about that. Those will cancel each other out and leave behind just the exponent, no longer in the exponent, just down there on the regular level as anything else. To finish this then and get y by itself, all I need to do is add 5 to the other side. So I have the natural log of x plus 5 is equal to y. So there's one way you can find an inverse when things get a little more complicated. And notice it follows, our prediction was, since we had a base of e, I should end up with natural log, and I sure did. Okay? Let me do one more that's a little more complicated. I'll give you another way to solve this one as well, instead of what we just did. So we start out with something logarithmic. Hopefully we're guessing that our answer will be something exponential, and probably should be 1/3 raised to some power. So let's begin by switching x and y like we did last time, especially for these more complicated ones. I like doing this. So x equals log base 1/3 of y plus 1. And so what I want to do, one way that I can change a logarithmic equation into something exponential is just go back and rearrange like the very first thing we did with logarithms. This number represents our base, so I'm going to write 1/3. This represented our power, so 1/3 to the x should equal y plus 1. All I'm doing is rearranging a logarithm the same way we did before. At the very beginning when we first learned about logarithms, this base raised to that power should be equal to this part of my equation, okay? And so now to get y by itself, let's just subtract 1 from both sides. So I get 1/3 to the x power, which is what we predicted we'd have, minus 1 equal to y. Again, if that seemed really complicated, if those were really tough, don't stress them too much right now. I promise you, once we start solving logarithms in a few more lessons, and we come back to this idea, it's going to be so much easier, I think.